Here we are on exercise 5 of chapter 12, and the goal here is to continue exploring the polynomial regression. So in particular, we want to go back to this data set here, which you will recognize from earlier in the chapter. This was the data set about doubling time of the human population. So how long does it take? How many years does it take until the population of human beings, so all the people in the world, doubles? So goes from 1 billion to 2 billion or 3 billion to 6 billion. So we have the doubling time on the y-axis and the year on the x-axis. Again, I discussed these data and how to interpret them and work with them earlier in this chapter. So what you want to do in this exercise is basically reproduce this figure, which shows the fit of a model to the data, a polynomial model, using a variety of orders from 0 to 9. Now, when I show this plot in Python, I'm going to talk more about it. I will interpret it and explain a bit what it means, and also talk about some of the numerical difficulties of determining a proper order for a polynomial regression. To run this exercise, you need the data that was pasted into a section earlier in the code on polynomial regression. So I'm going to rerun actually all the code from this section, although we really only need this cell here. These are the data, and yeah, here is where they come from. Okay, so let's see, I'll run that, and that, and that, and that, and that, all this fun stuff. Okay, so here we get to the exercises. So now we are at exercise 5. Where's exercise 5? Here we are. Okay, so the code is fairly straightforward. So we keep using this NumPy function polyfit, but here I'm fitting the data or the year to the doubling time. And here I call this variable oi. This is OI. When I'm coding in for loops, I often use an I at the end of the variable name. So that just helps me remember that it's a indexing variable. So this is the order index. In my mind, this is part of my own personal coding style. And so when I see my own code, then I recognize this as being an index variable. Okay, but still, just for fun, we can call it oi. So for oi in range n, and n is the number of data points. And again, all of these variables were created earlier in the code. So if if you just start running this code and you get a bunch of errors, then probably what's going on is that you haven't run the earlier code to create these variables. Okay, so yeah, in this for loop, we are just fitting the data, getting the predicted data values, and then plotting the real data here and the predicted data and the order. Okay, so now we have this figure, and now I can talk about this a little bit. So one thing I would like to notice is just about the curves, the bends of the data or the predicted data. So the black line is the real data. You can see that doesn't change for the order, right? The data are the data. And then it's these gray circles with a dashed line. This corresponds to the predicted data from the model. Now, a polynomial regression with an order of 0 is literally just fitting a mean. There's no slope to fit here. So this is just the mean value. So it's going to be a constant over all of the data points. So you can see this is clearly not appropriate here. Here we have a linear fit. Now, this is difficult to evaluate because you need to know something about the data to determine whether this is a reasonable fit to the data, whether this is a reasonable model. Now we know that, human civilization is changing. We know there's a story behind these data. So just predicting that the doubling time will keep decreasing over time is not appropriate. So this is not noise here. This is real data. So this is also not a very good model. Here we get to order 3, and you can see that this bend is really starting to be prominent in the data, and it's starting to capture this increase in doubling time, which basically means that the growth in global population is slowing down. I forget what year this was, but I'm sure it's in the 20th century. Here, you can see with order 2, that's a quadratic. So it's you can see there's a little bit of a bend here. But this is not a good fit to the data. Okay, but now, comparing orders 3 and 4, this is a little bit tricky because you can see, so if we focus in on these 2 points here, the model is underfitting the data here and overfitting the data here, and here as well. But, there's this bend in like this shoulder in the real data, which the model here is doing a better job of capturing, and here it's doing a worse job of capturing. So which one is better? The question is this just random fluctuations, or is this meaningful that the doubling time for populations was really, is really precipitous drop here? I'm not an historian. I'm not qualified to answer this question. So, but this is an example of how you really need to incorporate domain-specific knowledge when applying statistics to real data. The other thing I would like to point out here is you see, the model is doing extremely well here, right? The prediction is nearly perfect here for an order 9 model. So you might look at this plot and say, well, come on, Mike. I mean, why are you talking about this? Obviously, this is a way, way, way better model. We account for almost all of the data, but the issue here is one of generalizability. So the goal of statistics and model fitting is not to capture as much of the variance in the data as absolutely possible. Instead, the goal of statistics and model fitting is to have a reduced dimensionality expression of the data. So we want to have the simplest possible model that can account for all of the important features of the data. So the simplest possible model is that the data is just the mean. Now, this is not sufficient. We need a more complicated model here. And how complicated does it need to be? Well, this is, there are statistical approaches to evaluating this, like Bayes information criteria, for example, and there's other methods as well. But this is also a question for an expert in this field. So we would have to know something about these data and about history and population growth and decline in order to make an informed decision about which of these models is really the most appropriate one. Nonetheless, the point of this exercise is not about the history of human civilization. It is just about model fitting and understanding the implications of different orders of polynomials.